So, being from the Bioinformatics Institute, I thought it was important to write evolution on the. No, I think that it's probably poorly titled, but let me just introduce it a little bit based on Gary's remarks, which I think were really important, and many of which I confess I take serious issue with. I don't agree with Ed Glaser that cities have served us particularly well recently. I think they're an ancient idea, and I think they may very well apply to a much smaller population than we currently have, and that the use of the planet requires possibly a rethink, especially in view of the things that we can do that we weren't able to do before for many reasons, including share information. But it's important to realize that places like Cambridge and Princeton, they used to be in the middle of nowhere. Bologna, Camerino, great ideas came from there. And in fact, Alexandria was built and was pretty remote at the time that it was made, and only when the city people showed up did they tear it down. No, so the point of the comment here is that what I'm going to talk about is to rethink what it is that, in some sense, we are, and how that can affect how we make decisions that are enabled by information technology that has, changed so much so very recently. In showing the pictures of the cars that drive themselves, and we're all carrying around these computers that we call phones, and a variety of other things, what is absolutely true is that the interaction medium that's provided by infrastructure among individuals has so profoundly changed that what we even mean by interaction has been profoundly changed. So it doesn't matter whether you're talking about financial transactions or mate selection, old things that constitute social acts. They have been profoundly transformed, and they will play out in ways that I think are very hard to predict. And if there is one theme that I hear from Gary's presentation that I thoroughly agree with, is that the interdependence and complexity of these systems takes us away from any kind of real imperative for long-term prediction and puts us much more in a setting associated with management of an evolving system. And that's really what this is about. And you all know more about infrastructure than I do. I've studied the representation of infrastructure now for 25 years or so, but I've never actually considered myself to be really an infrastructure expert. I am a tool maker, and I'm a conceptual helper for people who are. And so I'll just start with this and go through it, and I'll be done. I may have to scurry in a couple of places. So if you look at a beehive, if you look at the honeycomb and you look at its impact on how it structures the behavior in the life of bees, it's a pretty interesting object. I mean, the features that are manifested by the beehive affect the individual biology of bees in the sense that each of the bees that you see here, they're different bees. There's a queen, there's some other worker bees, different kinds of bees. They all have, in that beehive, all those bees have exactly the same genome. They're all the same creature. They change from this form to this form based on a structured collection of behaviors managed in the honeycomb, associated with what food and hormonal environments are presented to the larvae. And they transform themselves into all these. The organism as a whole will collapse if these ratios are wrong, if they don't produce the right numbers of these things, and a variety of other reasons. But it's an organism that, to understand this guy, you have to understand those guys, you have to understand how they interact, what the signaling methods are they use, and the infrastructure in which it occurs. And so that's the question. Is that biology because bees made it? There's an example of bees recently, and I don't know, you probably have seen this, but maybe not. In Toronto, some researchers have found that there's a certain kind of bees, they're called leafcutter bees, and they've discovered plastic shopping bags. And their little mandibles will cut up shopping bags like they cut up leaves, and they build them into their honeycombs. And it turns out that the deterioration chemically of the plastic bags is a fungicide, and it improves the probability of survival of the larvae. So it's actually an adaptive change to the construction of bee infrastructure based on a natural relationship to its environment, but also sort of the creative induction of how to behave in an urban environment by bees. So this is a version. I know it's not a human version. It's a version of a co-evolving system inside embedded biological systems that are in interaction through plastic bags and through making honey and so on that people like and keep bees around, pollination needs. So there's this is not a casual question. The question is really, is infrastructure a natural kind in all social life? Is it a generality? And what are the conceptual, unifying tools and so on that we have? And how are we being affected in these general terms by the technologies? I'm going to talk about information technologies today, but we could pick other ones, but I'm going to talk about those. So what do we learn? So I said the first one, is it an integrating, naturally occurring feature of social life? How and does it change? And when it does change, how does that change us? How does the coevolution of infrastructures mean? And what does that have to do with resilience and planning and tools and management? And so what is the next generation infrastructure decision making and policy issue associated with noticing that the backcloth of interaction is both created and creates those who use it? So infrastructure dynamics in human infrastructure and all the biological frameworks that we come in contact with that are inherently social or otherwise, they're being upended by information technology in any number of ways. I won't go into those. I'll be faster than this. But by changing the structure of interactions, that is to say, interactions that used to happen in virtue of, say, physical proximity, being in traffic and noticing that it's stuck, going to a place and realizing that it's very hard to live there because the water's bad, or the people have cultural norms that are very difficult for you for whatever reason to deal with. Those kinds of interactions are transformed by being able to share information in ways that we now take as fairly commonplace that didn't even exist really 10 years ago in things like social media. It's not just some app. It completely is a restructuring based on layer after layer after layer of infrastructure, in this particular case, in the communication and computational world. The things that you have in your pocket not very long ago would be called supercomputers. You know, I mean, I'm in my 60s. When I was in undergraduate, they taught us to use slide rules. You know, this is really, it's very quickly changing, and those changes are affecting interactions, and they affect all kinds of stuff. Supply chain, where, you know, if you're a young family and you have children, the goal is to produce diapers at your doorstep before you order them, because they already know you're going to need them. And the reason to do that is to minimize inventories and increase returns to shareholders and minimize, you know, how much of this stuff you're putting in the landfill and losing and so on. Lowering price, increasing, well, I mean, That's kind of interesting. The supply chain where the consumer is the customer for a manufacturer is a huge innovation, and it's being driven by an infrastructure of interactions in computation and communication, and not by anything else. And it completely changes how you do things like build and deliver physical goods, how you share information, what information is shared, and what you're willing to share. Market trading is, we'll talk about margin trading. Margin trading isn't just the old market plus margin trading. It's a different market. It's a completely different market. And what we don't have is any way to predict the relative value of firms except run a market. We didn't replace that. We have to trade. Otherwise, you can't set the price. If you don't trade, you can't set the price. But we've changed the character of interactions that underlie the trading logic. And that's fundamentally new, and it's being driven by computation. It's infrastructure. Medical interventions. The amount of information that each of you can get online about whatever ails you or whatever you want to do is completely transformed medical practice. I just came back from a conference with the American Board of Medical Specialties. All the subspecialties have their own boards or certifying boards. And I will just tell you without further ado that this technology is upending certification process, diagnostic process, patient interaction process, billing process, completely changing the relationship between the healthcare system, the providers, and all the interested parties, pharma, all these kind of people, and us, the people that all that stuff is for. It changes everything, really, so I won't belabor it. But it's also changing science. One way of thinking about this is almost that some people say this. I take issue with this a little bit, but well, more than a little bit, but I understand the general focus of it, and you will too, that we've entered the post-modeling world. Okay, that and what I agree with it completely is these monolithic models developed by experts and delivered to deciders who decide for us and then we comply is over. Arab Spring is an example of it being over, but there are other much more benign issues of it being over. The Carlyle sort of great man theory of history is transformed. Decision-making processes are completely transformed by the existence of the infrastructure of these supporting this new class of interactions. So what we don't have is the old infrastructure plus communications, just like what we don't have is the old market plus margin trading. We have a whole new situation. So here's an example of something that describes a fundamental concept in this new environment on how we deal with data, how we think about things, and including us, individuals, are things in this sense. I just asked this question. Normally we think of ourselves as encapsulated. This is me, this is not me. I have properties, my motives and agency comes in, this is, well, unencapsulated agency is important. So I just ask you this as an example. Where is your money? Where? Simple question. There's no answer for it, but it's a simple question. Then where's your debt? So where are the processes by which your debt is serviced by your money? Aren't they your agency? Don't they possess themselves of your agency? I mean, stop paying your mortgage. Find out how much of your agency is not in your pocket, that is somewhere other than where you physically are. So there's a real conceptual problem with simple locality in this form of spatial locality or even simple versions of functional locality. When you talk about the agency of an individual, and our data systems, our communication systems, and our interactions have to respect this. And we are working on systems that allow us to go to massively large numbers of interactions, 10 to the 10th things interacting on multiple levels, not homogeneous things, to produce global properties and absorb, uptake information about all of these layers of relationships and interactions that constitute us, that do or do not live in you. This is a huge challenge for the analytics associated with the simple occurrence of all this communication and its subsequent sort of generation of massive amounts of stored data. So these massively interacting systems, it's not just among many things, but it's among many properties within each of these things. And this is really the challenge of having any sense of what's going on in systems like infrastructure systems, societal infrastructure systems, where this is the backcloth for nothing more or less than interaction. And so, so this is relevant to the study of it, and it's relevant to any conceptualization of how you're going to make decisions about it. I can easily show, so we've been obsessed with prediction for a while. We still are obsessed with prediction, actually. However, I will tell you that structural understanding of, I can find very easy situations by understanding the structure of an interaction. And I'll give you an example if any of you want. Is a very simple one. It's an old one. It's called a logistic map. A very simple thing. It governs things like predator-prey relations, all kinds of things. It comes up over and over. If you iterate this very simple equation, you can't predict what it's going to do. You can't predict the values that it's going to generate. But it's very instructive to understand the equation because you know that certain parameters move it into modes that are unpredictable and other parameters move it into modes that are more predictable. So from the point of view of understanding, we don't always just want to predict. So what is the synthetic independent self? Well, you interact with things on many different layers. In this particular picture, it's associated with different kinds of networks, infrastructure-related networks. And those lines, dotted lines that go down, those things that are not really encapsulated, that's you. You're the abstraction in this. But I mean, so these data structures, they adhere to the reality of the fact that you're more abstract than you think you are. You're not spatially local. You're not even functionally local. So each of these interactions are associated with certain kinds of infrastructure. So it's not too surprising if you change the infrastructure, you're going to get different you, and you're going to get different levels of emergent structure from that. And when you do things like add electronic and communication and computational data collection, transmission, sharing and stuff on each of these levels in between them, then it transforms each of those infrastructures. It's a new infrastructure in itself, and it completely changes the synthetic you. The thing that comes of it is unrecognizable to the thing that it came from, potentially. So unencapsulated agents exhibit unlocalized correlations. I'll give you an example of that right now, and I'll show you just what it is. So this is an example of a disaster in Washington, D.C. This was a model, a simulation, so it isn't the end of modeling completely, I guess, a very large one. I won't go into what the disaster is, except it really affected everybody in metropolitan Washington, D.C. And so these were three people, that avatars, inside this disaster, that if we just had data about the ground, ground data, measurements about where people are and so on, and nothing more, you wouldn't be able to notice that these three individuals at these discrete locations had correlated behaviors. But because inside a system that was informed by lots and lots of basically social and other infrastructure data sources, we knew that this constituted household members. And so the household members, after the disaster, actually behaved in a way that was correlated, if you understood what they were trying to do inside this simulation, was reconstitute their household, find their household members, and reconstitute the household, which turns out to be, since Hiroshima, since every disaster, since Katrina, any disaster you can think of, this is what people do. The correlations here that come out of this in understanding how to modulate, how to give people informatics, communication systems, and change those behaviors in order to enhance their probability of survival was the sort of thing that this study was about, that you would increase survival by merely enhancing, not running more first responders in, but enhancing their communication capabilities in order to make them participants instead of victims in their recovery. So infrastructure, repeating and repeating, is the medium of interaction. It is created and evolves. It co-evolves. It defines the structure of systems and their dynamics. It redefines individuals. It redefines who you are. It doesn't just add a layer. And the evolving communication and computational network infrastructure is transformational, not the old stuff plus something new. So there is how this changes things basically goes like this. The entire system has become viewable in one collection of things after another for causal explanations as a very, very large distributed computation. I know that doesn't sound like a happy thing to say to maybe to some of you, but it is extremely important to realize that the analytics have as much to do with using the system as an inherent computation as it does with extracting information and computing it somewhere else. And those kinds of ideas and how to implement them are also transformative, and they're brand new, and they form the basis of the kind of research that we need to do aside from reactive discussion of one thing or another. So what I call the inside-outside problem has many shapes, but I will just say this, is that scientists and policymakers are no longer outside the system because data and assets that compute data, generate data, move data, they're available to everyone. I was just in Uganda, and I was in a place, Kampala is one of these cities that's growing along, if you want to call what it's growing into as a city. It's more like a giant encampment around a city, but everybody has a cell phone. Most people have two. And, so anyway, so the dynamics are occurring inside and outside the data medium. The entire social system is usefully viewed as computational for the reasons I just described, and everyone is a data generator, a data consumer, and a decision maker. Everyone, not just the decider. And that's new because we've never had access to information like this before, ever. And so I would say that it's important to realize that synthetic information environments, big data synthesizers, whatever you want to call them, is an extremely important collection of not just tools in the form of, computers and guys sitting around and things, making apps and selling them to you, but in terms of the conceptualization of how to even think about who a person is, what a place is, how people interact with other people, and how they're affected by things that play out through these interactive media that we call infrastructure. It's a natural kind. You can see it in bees. You can see it in a lot of other things. It deserves serious attention, and we as scientists owe you as practitioners the very best research and development issues to move this stuff into practice as quickly as we can. So or at least as quickly as possible. And I would say that that challenge is what motivates most of the scientists that you see here. That challenge is something that spans every single thing we know how to do. It isn't, less than astrophysics or something like that. This is serious. And I think largely because that we can't really avoid the communication piece of it, that much of what Gary talked about, the management of our cities, the development of an understanding of the relationship of what a modern city even means, how we use the landmass, how we decide if you want to claim these things are efficient, more efficient than this, there's something is more efficient than another thing. I really don't think we understand the supply chain, the footprint of these things in any kind of way sufficient to really come to any of those kind of conclusions. And it's just an extremely exciting time, as well as sort of a worrying time to be associated with it. And this is what we're about, is synthesizing this sort of information into actionable tools for the questions and the setup of the issues that you'll raised today. I mean, today and tomorrow. Thank you.